Back, guys. Today we are back with another problem, and today's problem is solving the circle of strings. Okay, so this is categorized as a hard problem, and before we solve this problem, we will be first thinking about how to improve our strength in the category of strings. What are the manipulations we can do with the string, and so on. So before you go on and checking out this video, just go and check out my DP series and also check out my string series, so you guys will be understanding what is the concept of hard problems which can come in the field of strings. Okay, so strings is a very broad field. It can have very simple conditions like deletions, removal, insertions, and it can also go as hard as this particular one, which can even consist of graph problems and edges. So how we are going to solve this particular problem? Let us understand this. We're saying that we're given an array of lowercase string. Determine if the strings can be formed together to form a circle. A string x can be chained together with another string y if and only if the last character of the x is the same as that of the first character of the y. If every string of the character will be chained with exactly two strings of the first two strings of the array, one with the first character and the second with the last character of the string, it will form a circle. For example of the array, you can say a check for geek. The answer will be geek, for geek, rig, calf. Okay, so it is saying the answer will be yes, as the given strings can be chained as for, rig, geek, and calf. Okay, these strings can't be form a circle. So you have to check if the strings can be changed together. So what you can see, they have given the array. First, the array is saying that for, geek, rig, and calf. So they have now changed the locations also. They have changed the locations of the elements. Now they have made it as for r, so that this r and r comes closer, and this g and g also makes a chain, and k of the calf and the geek makes the chains. Okay, so let us try to analyze this particular problem statement with the help of another example. Maybe that will make it more clear. Okay, so let us take another example. Say a, b, c, b, c, d. Okay, and CDF. So I'll just use this. Yeah. So if I see in this particular problem statement, in whatever way we can arrange this particular problem statements, can this form a string? So our first task is to arrange it into number of ways. So when I'm getting A, B, C, B, C, D, first I'm checking this is ending with C, this is ending with B. So can I put B and C together? No. So what I can see is A, B, C. I am checking another string. It has C, D, F. Okay, C, D, F I can put. Now this is ending with F, and the second string is B, C, F. B, C, D. Now you can check that this is not ending with the same values. So this, for this case, the output will be 0. Means there is no possibility. So let us try to take an example of a possibility, and then let us check whether we can solve this particular problem or not. So in my string array, say for example, if I take this set of values a, b, b, c, c, d, and d, a, b, b, c, c, d, and d. So now if I check, okay, so b makes a sense with b, c makes a sense with c, d makes a sense with d, and the most important part is to make a strongly connected component. Over here you can see a is again connected to a. So that means this particular string will form a circle. So I'm going to return 1. Okay, and this is a possibility. Okay, so before going there, let us understand how we can solve this problem. First, let us draw some constraints. Okay, so constraints is everything should be in lowercase. Okay, this is one of the constraints. Okay, second constraint, what we can see, we have to determine the size of the string which can form. Determine if the string. Okay, so we can say check circle function. We can have to make a check circle function. We can pass a string value over here and to check whether it can work. If the chain is if the last character of x is, so what we have to check is, suppose we have strings. Okay, suppose we have str1, str2, str3 strings in this particular order. Str1 of last has to be the first character of this two has to be equal. Similarly, this two has to be equal, and the cycle goes on. And the character at the end must be also equals to the character at the start. So means this particular value has to be equivalent to this particular value. Okay, so these are the conditions. What else condition? If every string can be changed with exactly the string in one direction with first and second, it will form a circle. Okay, so what it is saying, that every string of the array can be changed with exactly two strings of the array. Okay, one with the first character and second with the last character. Yes, this is obvious. So if I'm taking example of this particular statement, the second character is forming a chain with this particular, and the first character is forming a chain with the last character of the last word. That means it is this is a strongly connected and strongly connected graph. Okay, so these are my conditions. So let us analyze how we are going to solve this particular problem statement. So what we can clearly see is, this is a problem of graphs and edges with DFS, okay. So my first task is to write the sentence, okay. So my sentence initial string, suppose if I'm given with the string, I can say string str equals to abc bcd and abc, sorry, I have to just make some changes. So my string will be ab bc cd and d. I'm taking this particular string, it can be a word, it can be a complex thing. Your task is to do this particular thing, okay. So what I'll be doing is I have to make some edges, right? So what I will be doing is I'll checking a is connected to b, okay, and then b is connected to c, okay, c is connected to d, okay, and d is connected to a, okay. What I will be writing over here is we are exactly forming one edges from the nodes a to b. So we can say forming edges from node a to b, okay. Similarly we can write node b to c, okay. We can write node c to d, and lastly the last node is also connected, so I can write it is also forming a edge from node d to a, okay. Now we have to check the in degree and out degree element. So this is one of the strongest conditions of check we can place, is checking if in degree value of this particular graph is equals to out degree value at any particular instance value at any particular instance, okay. So let us try to understand. Now if I take this example abcd, what I'll be doing is I can easily write, if I'm considering for a, there is one incoming which is from d to a and one outgoing, so I can write one incoming and one outgoing, okay. Now let us take another example which is b. So in this b, one is incoming and one is outgoing, so in b also I can write one incoming, one outgoing, okay. Let us check for c, one incoming, one outgoing, one incoming, one outgoing. This value has to be checked. Now lastly for d, from d one is incoming, one is outgoing. For d also one incoming and one is outgoing, okay. So all the incoming and outgoing edges have equivalent values. You can see carefully, have equivalent values of 1, 1, 1, 1 and 1. That means my number of in degree elements is equal to the number of out degree elements, okay. Now comes the third level of checking, which is the last and final checking, to check if it is strongly connected or not. So what is the condition of strongly connected? Strongly connected means there has to be, it has to start from A, okay. Now the graph is going to B, the C, D, and the graph has to return to this particular value A from where it has started. So this is the condition of strongly connected. Means the first value from where I'm starting, I must return to where I started. I started from here, I went all these directions, but I came back again to this direction. That means it is a strongly connected graph, okay. So if all these conditions are satisfied, so we can say therefore it is a circle. And this particular string forms a circle, okay. Now let us go and try to code this particular sample of string and see whether this actually works or not, okay. So I'll go over here, okay. I'll just try to do this. Maybe a bit of presentation to this particular string will help. Yeah. So as you can see that I guess the face is on that side of the screen, so I'll be like, okay. So what we can see is we have to make a circle. Int circle means this particular method will return whether it is 0 or 1 depending on whether this is a circular string or not. It will return 0 or 1 depending on whether it's a circular string or not, okay. So initially I'll be checking the length of the string, okay. So I can write n equals to since the name of the string array is length, because there are multiple words, I can say int end equals to length, okay. I'll be having the base cases. If the n is equals to 0, what I can simply do is return 0, okay. Now I have to make the adjacency map. What is adjacency map? Each each particular letter with its edges. Okay, so we are going to make the adjacency list of the particular graph which we are trying to calculate or make. So I can write simply map, and I can write simply map. So I can write it like this, character. Okay, I can write it like this, map of character comma list. Okay, and in this list also we are passing character. Okay, once it is we have passed character, we can name them list. We can name the map as abc equals to new hash map. Okay, hash map is a very important concept. We have solved a lot of problems on hash map, but it gets interesting as more problems we are solving. Okay, now our task is to we have to check the number of in degree, means the number of total incoming and outgoing edges. Total incoming and outgoing edges. So we can consider the incoming and outgoing edges as what I can see is okay from A to D, but since the strings are of lowercase characters, the possible value which my array can contain is from 1 to 26. There are 26 lowercase characters in the English dictionary. So I can write incoming degree. So I can write in degree equals to new int of 26. Okay. Now similarly, the number of outgoing edges is also there. The maximum limit of the outgoing edges can also be 26, because there's 26 values which can go back as well. Okay, so I can write this as in degree and out degree. Now I have to construct my particular graph. Okay, so I can write graph of string s presenting string r. Okay, and I have to give a starting point. I can take s dot caret of 0, means the first index of that particular string. For ABC, A will be the first one. Okay, and for end, it is very simple. What we are going to take, we are going to take the length. So we can say s dot caret of, we can easily say s dot caret of s dot length. Okay, minus 1. We have taken the starting and the ending values. Okay, now I'll be writing graph dot is absent start new array list. Okay, we can write graph dot get the start value dot add the end value. Now how we are going to increase the counter of the number of outgoing edges? We can write out degree. Out degree is from starting to, means the start count is being increased. So I can write start minus of a plus plus. Now it's an interesting question. You will be asking why we are doing minus of a. Minus of a does help us to return the value of that particular thing in the form like the ASCII value. So a is 65. So if you subtract 65, so you will reach that particular count of the character. So if I am at 65, is if a is 65, so 65 minus of within single quotes a, which is 65, will give me 0. So my starting node is 0 initially, which means the array's first element. Plus plus means we are increasing the counter. Similarly, we have to do with in degree, and since the in degree is being the node which is added to the end node, means it's an incoming degree. Okay, so we can write end of a. Okay, similarly end of a plus plus. We have now checked both the counters of in degree. Okay, now our last and final task is to check whether it is the second check condition. The second check condition is where did I go? The second check condition says that if the in degree is equals to the out degree exactly. So what I can write is I will just for int I equals to 0. Okay, I less than 26, I plus plus. Okay, so I can write clearly if in degree of I is not equals to out degree of I. Okay, then I will be returning 0. If it is equal, then obviously some other value. Okay, so that is also done. Now what we can do is lastly we can check whether the graph is strongly connected or not, whether the graph is particularly strongly connected or not. So I'll be just make a strongly connected function. Okay, I can write it, I can make the function out of here. So what I can make the function is boolean strong check. In the boolean strong check, what I'll be passing is a character of the starting value. Okay, and a map of frequency map. So I can store a map character. Okay, so map character, yes, list same type of character values. So in the list we will be passing characters. We'll be passing characters, and we can name this particular list as ABC as well. Okay, we can name this. So one thing I have done mistake. I have taken ABC over here, but I'm using graph everywhere. So I will be making this as ABC. It's up to you. You guys can do whatever you want. There's no restrictions on naming variables. So we can check the list value as also ABC. Okay. So once the graph is made, we can have an N. Okay. And we can start the strongly connected component check. Okay. So first is we are going to store the elements in a hash map, whether it's visited or not. Okay. So we can clearly write hash set. We can clearly write set of character. Okay, visited equals to new hash set. Okay, set of visited characters as new hash set. And since we have to check all the deepest point of the graph and all the other values, what other things goes well with this type of graphs? A DFS function, right? So I can write private void DFS, okay, which will help me to grow through it. So I can, in the DFS, I can pass a node, character node, a map of character list character. Okay, that's a pretty long code. Yeah, character, and what else do we have? We have a set of characters. So we can say ABC comma set of, we can say ABC comma set of character. We can say ABC comma set of character, and I can say them as visited characters. Okay, and that's all. So I'll be checking it. So I'll be putting the visited dot add node. Okay, if ABC dot contains key value of the node, we'll be doing a depth first search traversal. How we are going to do that? We can traverse it from the character. So we can say this is my neighbor, right? So I can name this value as neighbor, and it will go till ABC dot get. Okay, we'll be having a node. And we will be putting an if condition. If this is not visited contains the neighbor, not visited contains the neighbor, we are going to recursively call as depth first search works with the help of recursion. We'll be recursively calling this neighbor graph and visited. Okay, we have to check this if condition, for condition, if condition, the main visited array is done or not. Now let's come back to the strong check. In the strong check, what we are going to do, we are going to just simply call the DFS function which we have created below and pass the start. Okay, we have to pass the graph ABC, and what else do we have to pass? We have to pass the visited sets. Okay, we have to pass the visited values, and then we have to return the total size of the value. So visited dot size equals to n. Okay, so means if the sizes of the number of edges becomes equals to all visited, that means it's a connected graph. Okay, so this is also done. Our function is also done. Number of in degree, out degree is done. What else do we have? Do we have anything left? We have to give it a check. Okay, so we have to check this value. Okay, so this is done. Lastly, we are going to check for strong check, right? So we can write if this is not strong check, means strong check is not true, strong check gives a false value, then we have to pass the values, right? So I can write ARR of the starting value as ARR of 0 dot char at of 0. Okay, these naming conditions are very crucial. Okay, then we can pass ABC, comma length, total number of edges. Okay, we can return 0, or if the condition is true, then we are going to return a 1. That's out. Let us compile. Okay, string s dot str, so this is array. Let us compile. ABC dot is ABC dot is absent. Okay. Okay. E is absent. Cannot find symbol. Start. Why is it so? Visited. So we have to check the ABC dot. Sorry, I just put if. So the command is put if. Yeah, this should work. Cannot find symbol. Not visited. 73. That contains neighbor spelling is wrong and it's neighbor. Okay, cannot find. Again we have made some mistake, so let us check. We are taking character node, character of map ABC, set of visited characters, visited dot add node contains key for character in neighbor NEIGHBOR BOR not visited DFS graph graph. Sorry, this is ABC. When am I writing graph? So yeah, this works. Let us submit our solution. Oops, it is saying we have passed only 3 test cases. So that's bad. As we can see that we can see carefully that this is not passing all the test cases because this is not handling the case where if the list is list is reversed, if all the particular test cases are not passing. So that's a complex issue to be solved. So what I came up with a efficient solution is what I can do is the way I have written this for adjacency list ABC, I'll be having another list for the reverse adjacency list. Okay, so I can write rev ABC or I can say rev ABC. Okay, so in the reverse adjacency list, once I'm done with this, what I'll be doing is the way we are putting start dot add and start dot add. So I'll be having another line. Okay, I'll be having another line, and I can call this as reverse adjacency list. So I can write rev of ABC. Okay, so in the reverse we are going to start from the end. Okay, so we are going to start from the end, and similarly we have dot adjacent dot get start. So we have to add another one. Okay, so we can write it like this. We can, let me just think, it can be ABC dot get. So this is rev ABC. Okay, the reverse adjacency list is also done. The ingoing and outgoing degree nodes are being added. Okay, the ingoing and out degree nodes are added. So we can so what we are checking, out degree of a plus plus, in degree of n minus a plus plus, nodes dot add. We have taken any nodes. So we have to take the hash set of the nodes. So we can write hash set of character nodes equals to new hash set. So I've made the node of the entire hash set values, and once the hash set value is being made carefully, I have to add the nodes somewhere over here. So I can write nodes dot add. So I can write nodes dot add of start and nodes dot add of end. Okay, so this is still here. We have checked all these values. Let us check the in degree count. Check for in degree count of every character. So I'll be checking the in degree count. So I'll be just modifying this particular code. I can write for my character node is present in nodes. Okay, this is the node iterator. So if in degree of node minus of similar condition I will put is not equals to out degree of node minus of a. Okay, so I've checked the in degree and out degree, both the in degree and out degree. If it doesn't match, I'm going to return a 0 straight away. Now let us check the strongly connected components. So if not strongly connected array, we are going to pass. Okay, so we're going to make some changes over here. So our DFS function will be exactly same. For strongly connected, we are going to have another list over here. So I can write it. I will just, the code is going to get a bit longer. Can't help. So here, so we can write rev of ABC, the reverse adjacency list, and we are going to pass the n value. Okay, so we can write it over here. Set of character nodes. We can write set of character nodes. So this is how we can solve this particular problem. It's quite complex, but we're going to work it out. Okay. So once the set of complete characters are done, we are checking this. We're having a set of visited. This remains the same. We are DFS start, then adjacency list ABC visited, return. So we just have to change another time. We have to run DFS again. So what I'll be doing is, if my visited dot size, if my visited dot size is not equals to nodes dot size, okay, I've checked the if condition, then I'll be returning a false. Okay, and I have to run the second DFS as well the similar way. So I will clear it out using clear function and DFS, okay, from start, okay, reverse adjacency list ABC and visited as usual, okay, return visited dot size, nodes dot size. We have to return the, now let us compile. So we have another error. Rev ABC. We have taken a rev ABC. We have taken a list map character rev ABC. What else? Visited start rev ABC visited. This if is there, visited done. We are again calling the DFS function. Okay, we are again calling the DFS function start and visited. So this is not a function. Why did I write it like this? So just compile. Okay, strong check in class 69. Okay, so then the strong check function also, since I've now updated my strong check function, so I'll be updating array caret 0 ABC, and there will be one rev ABC, reverse adjacency list. Instead of n, there will be nodes. Oops, 76. Cannot find boolean strong check character start class character start. Okay, we are having a map of character list. So boolean check, we are having a character start, we are having a map of character list of the ABC map character. Oops, map character. So we are having a map start map character list of ABC. Similarly, we are having a map character list character rev ABC. So this character has to be of capital. Let us compile. Submit. There must be some error again. Throwing too much errors. This is throwing too much errors, so let's compile. Null pointer exception in class GFG. What is that null pointer exception? Oh, so let us try to understand this code once more. We have had it dot length, return 0, if adjacency map. We have made two maps, two hash map, reverse. We have a hash set even. Okay, we can write hash set even, new hash set. Okay, we have the in degree values 26, out degree is 26, string present in the array, starting of this length -1. Okay, then we are just putting abc.put if absent, start and new array list, then reverse abc.put if absent, end new array list. Then we are doing abc.get start.add end. Okay, reverse abc.get end.add start. Okay, we are doing the same thing. So this is end and this is start. Let's compile. Let's submit. So this is a big chunk of code. Now you can see that we have successfully completed all the test cases. So make sure you guys like, share, and subscribe. This type of problems don't come in normal questions. So if I see company tags, Flipkart, Amazon, stuff, they have asked these questions in the future. So make sure you guys like, share, and subscribe to the channel. Thank you so much.